Hello everyone, welcome to our statistics channel Quality Statistics. Today we will discuss concept of skewness. In the previous video we discussed concept of moments. Now literally skewness measures lack of symmetry. We study skewness to have an idea about the shape of the frequency curve which we can draw with the help of the given data. The frequency distribution of a discrete variable x is said to be symmetrical about a value x0 if the frequencies at x0 plus minus h are equal for all possible values of h. Now, by the following figure, when we take discrete values, then we get this type of figure for symmetrical distribution. The left parts are gradually rising, reach top, and right part gradually decreases. Again, the frequency distribution of a continuous variable is said to be symmetric about value x0 if the frequency densities at x0 plus minus h are equal, whatever h may be. Now, by the following figure, we see that this is a curve and reverse U-shaped curve, bell-shaped curve, and this is the highest point at x0 and the left part is x0 minus h, right part x0 plus h. This is symmetrical distribution for continuous variable. Now with respect to this type of figure, we can write mean equals to median equals to mode because it is purely symmetrical. A distribution which is not symmetrical is called asymmetrical or skewed. The skewness is said to be positive if the longer tail of the distribution is towards the higher values of the variable and negative if the longer tail is towards the lower value of the variable. Now, by the following figure, we can show this is positively skewed distribution and this is negatively skewed distribution. Now, whether a given distribution is skewed or not can be tested by one of the following ways. If the graph of the frequency distribution does not portray a symmetrical curve. Number 2, when the three measures of the central tendency, that is mean, median and mode, do the coincide. Number 3, when the sum of the positive deviations from the median are not equal to the sum of the negative deviations from the same. Number 4, when the numerical distances from the median to the lower quartile and upper quartiles are not the same, that is quartile 3 minus median not equal to median minus quartile 1. This mi actually is q2. Now we focus on measures of skewness. Measures of skewness tell us the direction and extent of asymmetry in a distribution and permit us to compare two or more distributions with regard to these. They may be either absolute or relative. Now we focus on absolute measures of skewness. Skewness can be measured in absolute terms by taking the difference between mean and mode. Symbolically, skewness in bracket absolute equals to mean minus mode equals to 3 in bracket mean minus median. When it is based on quartiles, this becomes skewness sk in bracket absolute q3 plus q1 minus 2q2. Such a measure is unsatisfactory on two grounds. Number 1, it would be expressed in the unit of value of the distribution, and two distributions cannot be compared when they are expressed in two different units. Number 2, distributions vary greatly and the difference between, say, the mean and mode in absolute terms might be considerably in one series and small in another. Now we focus on relative measures of skewness. Number 1, measures based on the positions of the mean, median and mode. Number 2, measures based on moments. Number 3, measures based on quartiles. and number 4, measures based on deciles and percentiles. This is all about today, and please keep watching our channel for new videos and updates. Thank you all for watching this video.